Welcome to the session on security best practices the well-architected way. My name is Lee and I'm a solution architect with AWS. In today's session, we'll cover a brief overview of the well-architected framework, and we'll take a closer look at the security pillar and the 5 areas that make up the security pillar. The well-architected framework helps customers understand the trade-offs of the decisions that they make while deploying cloud workloads. Using the framework, you will learn the current architectural best practices for designing and operating a reliable, secure, efficient, and cost-effective solution in the cloud. It also provides a way to consistently measure your workload against these best practices and identify any areas of improvement. We believe that having a well-architected framework greatly increases the likelihood of business success. Asking yourself, are you well-architected? By answering the questions and following the guidance in the well-architected framework, you can answer this question. Incorporating the best practices of the framework will ensure that you build a robust, performant, cost-effective application that can scale with your business. There are 5 pillars of the well-architected framework review, and the focus of this session is the security pillar. The well-architected tool is available in the console, and if it's not available in your current region, you can always default to the North Virginia region. I encourage you to use it as a learning tool by starting a dummy workload and so that you can familiarize yourself with the best practices and the guidance of the framework. Let's focus on the security pillar of the well-architected framework, identity and access management, where we consider the implications of specific processes related to IAM and how they improve our security. Detection of potential security misconfigurations, threats, or any unexpected behavior within your environment. Infrastructure protection encompasses control methodologies such as defense in depth that are necessary to meet the best practices and organizational or regulatory requirements. Data protection by way of data classification for sensitivity levels of data, or encrypting your data, making it unreadable to unauthorized users. And lastly, incident and response, to respond to and mitigate the potential impact of security incidents on your environment. Security is a shared responsibility between AWS and yourself. During the course of this presentation, we'll reference this architecture as a simple WordPress site on an EC2 instance with Lambda for additional compute, EFS and S3 for storage and static content, and SNS for notification services. As you can see, we've already rated this architecture against the well-architected framework, and we've got a lot of high-risk indicators that need to be taken into consideration. Our first stop is incident and response. And even with extremely mature and preventative controls, your organization should still implement mechanisms to respond to and mitigate potential impacts of security incidents. The preparation here strongly affects your ability of your teams to operate efficiently during an incident and isolate and contain issues and to restore operations. Putting in place the tools and access ahead of time and routinely practicing these with game days, playbooks, and runbooks helps ensure that you can recover quickly while minimizing business disruption. A good starting place here is Amazon Guard Duty in the findings and alerts sections. Enabling Guard Duty allows your organization to educate and prepare. Educate your security operations and incident response staff about cloud technologies and how your organization intends to use them. Prepare your incident and response teams to detect and respond to incidents in the cloud. Enable detective controls, which we'll look at a bit later, and ensure the appropriate access to the necessary tools and cloud services ahead of time. Prepare the necessary runbooks, be it automated or manual, to ensure reliable and consistent responses. Working with your teams to establish the baseline of operation and using this knowledge to identify any deviations from normal operations allows us to simulate and iterate. Simulate both expected and unexpected behaviors within your cloud environment to understand the effectiveness of your preparation, to iterate the outcomes of the simulations, and to improve this and scale the response posture we have, and thereby reduce the time to value and further reduce the risk. These approaches put together form the foundation of incident and response plans to mitigate and respond to security incidents in your environment. Let's have a look at our architecture and how we've chosen to enable this. We've enabled Guard Duty, the findings and alerts. We've also got our playbooks, incident and response tools, and access ahead of time. This is the 10th question in the framework. And now that we've added these tools and followed the guidance, we've got less high risk indicators within our environment. The next area of the security pillar of the well architected framework is identity and access management. To use services in AWS, you must grant users and applications access to resources in your account. As you run more workloads in AWS, you need to have a robust identity and management systems in place to ensure that the right users have the right access under the right conditions. AWS offers a large selection of capabilities to help you manage both human and machine identities and their permissions. Automation for credential management can save organizations a large amount of time reviewing permissions, while improving your security posture by ensuring that permission allocation and removal is done consistently, taking into consideration processes like joiners, leavers, movers, disabling and deleting of access keys, and that there are no hard-coded usernames and passwords when necessary. IAM should also adhere to granting the least privilege access, analyze public and cross-account access, and reduce permissions consistently, as well as establish an emergency access process. To help minimize the impact of delegating permissions, you can take advantage of permission boundaries in AWS to set the maximum permission that an identity can have. This enables you to delegate the ability of account creation and account management to specific teams, such as developers or admin teams, for example, while limiting the permission that they can grant so that they cannot elevate their own accounts. With permission boundaries, you can maintain good security practices, but allow the right amount of flexibility for your teams to take advantage of the self-service nature of the cloud. Another useful feature here is the assume role function, which issues temporary credentials to AWS resources with no need to assign permanent credentials to the service in question. Additionally, you no longer need to hard code any usernames and passwords into your application that could be compromised. Using the assume role can reduce the management associated with managing service identities while improving the overall account management processes. A good customer success story is Westbank. Westbank are using the AWS security products, and while not having had to build these products on their own, while still managing to meet their security requirements. Let's have a look at how we apply these to our architecture. Enabled AWS organizations to create policies and permission boundaries. We've got IAM with assume roles on our EC2 instance, SSO and MFA to provide a single user access as well as multi-factor authentication. And this is the first three questions of the security pillar of the well-architected framework that we've now taken into consideration and have less high-risk indicators in our architecture. At the same point in time, I've chosen to enable some management tools that will help me better manage my environment. CloudFormation for infrastructure as code, Systems Manager to provide SSH functionality, as well as code services to store my code for infrastructure as code, and CloudWatch events to set up notifications within my account of items that I would like to be notified about. Our next stop is detective controls. And in this section of the security pillar, it deals with detecting change and routing this information to the correct team or alerting group. Asking yourself, do you still have visibility? Do you know if there's been any changes? Is there anything abnormal happening in your application that you need to be aware about? Detective controls enables you to identify potential security misconfigurations, threats, or unexpected behaviors in your cloud environment. It's an essential part of the security lifecycle that can be used to support legal or compliance obligations as well as threat detection. There are a few different types of detection mechanisms. For example, analyzing the logs from your workloads for vulnerabilities or exploits that could be used. Your VPC flow logs that can be used to identify any abnormal connection pattern behaviors, or performance metrics to detect any misconfigurations in your application. You should regularly review the detection and mechanisms that you have related to your workload to ensure that you are meeting your internal and external policies and requirements. Earlier in my architecture, I enabled some management tools. I'm now going to use those to automatically enable detective controls on my environment, starting with CloudTrail and some basic alerts that I would want insights into my environment, guard duty, and more detailed alerts of findings within my environment, and then AWS config that allows me to see a change history of all my resources on a timeline, as well as the ability to get notifications and react to those changes. All of these put together give me access to config rules, chatbots, auto escalations, and auto remediations, which are all good alternatives as opposed to just email notifications. How are you doing threat modeling? Because you need to know what to look out for, and every threat has a mum, a method, an opportunity, and a motive. Using these models, you need to determine if you have, based on a threat, got the appropriate detective controls in place. When deciding what to look for threat modeling, we have the preparation phase. So it's not just about the logging, it's about setting meaningful thresholds within those logs. It's about automation, using automation where possible to automate your notifications. And it's about the ability to deep dive into the health of your application so that you know or can detect when something is going wrong. Insiders can be intentional or unintentional, checking for where you've lost certain visibilities on your dashboards or any unused resources that could be used to exploit your application. And lastly, we have recon. A recon is really important. Taking a look at something like your DNS logs, for example, at a /admin or a /login page, and comparing those connection pattern behaviors to your actual logins to determine whether this is normal behavior or abnormal behavior. Lastly, detective controls is about the continuous evaluation of your environment, what you're doing and what's happening within your system. As an example, you can use the CIS benchmarks in AWS config rules to get started. Back to our architecture now, and let's review what we've just done and the controls that we've added. We've enabled guard duty, which I enabled earlier as part of the architecture for the findings in the guard duty for good detective controls on the dashboard, as well as CloudTrail alerts and AWS config for change history and change history tracking and CloudWatch logs. By enabling these detective controls, I've now further aligned to the best practices in the well-architected framework. Our next up is infrastructure protection, which encompasses control methodologies such as defense in depth that are necessary to meet the best practices and organizational and regulatory obligations. Infrastructure protection is a key part of your information security program. It ensures that your system and your services within your workload are protected against unintentional or unauthorized access and potential vulnerabilities. A good example of this type of architecture is a single ingress and egress VPC that can scale to hundreds of accounts. On the left-hand side, it gives you the ability to have fine-grained control of traffic coming into your VPC, and on the right-hand side, the same amount of control for traffic leaving your VPC, as well as the ability for additional monitoring such as URL filtering or DLP proxies. In this example architecture, the transit gateway is the center point of control that's giving you that fine-grained access to your network traffic. There are many different types of architectures that you can deploy depending on your requirements. VPC sharing and resource access manager also help protecting your infrastructure by sharing specific infrastructure element and providing that segregation between teams creating the VPCs and teams needing to use the VPCs. This sharing has a very specific use case where you have multiple different teams that want to share resources within a VPC. In the design, we also take into consideration instance level protection with security groups, as well as subnet level protection with network access control lists. Infrastructure protection can also be automated. In this example, we have an AWS WAF that's protecting a CloudFront and an application load balancer. We're then using Kinesis Streams or Kinesis Firehose to port those logs into Amazon S3. Athena, the ability to scan those logs, and an AWS Lambda log parser to then notify and update my AWS WAF when an attack is detected, such as an HTTP flood attack. Another example of this is using CloudWatch events on an hourly basis to trigger a Lambda that gets the latest IP reputation list and again updates our WAF automatically to ensure that we are continuously protected. A very similar method can be used with API Gateway and Lambda again. There's also open source tools like the Open Web Application Security Project. Awesome projects out there like their dependency checker. If you're using open source tools like Jenkins for your code build pipelines, there's a plug-in that allows you to do dependency checking at the code layer, or no package managers auditing and fixing at the command line layer. And then, are you doing fuzzing? Now, fuzzing is the ability to do different things in your application. Like in a web form, for example, test for SQL injections or malformed requests. And it's really about testing your application for these vulnerabilities and which ones exist. There's a number of fuzzing tools out there, and I encourage you to look at these and run them against your application. Simfi Africa took advantage of the AWS VPC security group and IAM to ensure that the infrastructure is protected and that they have better security at the infrastructure layer. Now we go back to our architecture and have a look at how we've implemented all the infrastructure protection. At the perimeter layer, we've got Route 53, CloudFront, and AWS WAF that's protecting our perimeter. We have then segregated all the other layers into individual layers, starting with an application load balancer for ingress traffic via a NAT gateway, a private subnet for our instances, and another private subnet for our database. All have individual route tables and network access control lists that give us fine-grained control of what can access which layer. Lastly, I've enabled Security Hub that gives me a centralized dashboard for my inspector logs as well as my guard duty logs. And we can see we're even better aligned to the well-architected framework in our architecture by implementing the infrastructure protection. Our last stop is data protection. And before architecting any workload, foundational practices that influence security should be in place. For example, data classification provides a way to categorize data at different sensitivity levels. And encryption protects data by way of rendering it unreadable by unauthorized access. These methodologies are important because they support objectives such as preventing the mishandling and unauthorized access of your data. Keeping your data away from people. Do you have to store your data? And not everyone needs access to your data. Using encryption, masking, and tokenization to further protect your data and make it unreadable to unauthorized access. And we can also using tooling to eliminate direct access to applications such as Systems Manager that can be used to protect SSH and give fine-grained access control. Operations as a code and version control can also be used to protect data while eliminating direct access to the applications when needing to update code repos. Data exfiltration is definitely something to think about, and it started off with host-based protection with a simple agent running on your server that used to detect data access patterns using a watermark, for example. Nowadays, we have other vectors to think about, such as SaaS providers and partners, and what access they have into our accounts and what access they have to our data. A DNS logs via text files can also be used for data exfiltration. And how do we protect against these? By having security services such as guard duty, the correct incident and response in place, and detective controls. A logs is a very interesting one, where logging verbose information into your log can actually log pieces of sensitive data into your logs. Knowing where your data is stored and is a good place to start, and consider all data sources that you have. Using CloudWatch and watching for pre-signed URLs is a good way to monitor specific API calls that could give you insights into how your data is being accessed. S3 custom access logs is an example of how to add a key value pair. Example of a shortened URL on the screen with the X dash code at the end, which is the key value pair that you can use to denote certain sensitivities of your data. I wouldn't add top secret in here. That's just going to be a giveaway. Add something that makes more sense for your organization. KMS encryption can be used to encrypt your EBS volumes and snapshots to protect your data volumes at data at rest. And you can also apply a context to the encryption key, very similar to what we did with S3, thereby giving you insights from your logs to what is being encrypted and what is being decrypted. If we go back to our architecture now and have a look at how we've implemented these controls, I've used Certificate Manager for SSL certificates on CloudFront and our ALB to give us protection in transit, DLP at our egress layer, and I've used KMS to encrypt our instance volumes as well as the database. And lastly, Amazon Macy, so that I know about any PII data that I have and how it's being accessed. As you can see, we're now well aligned to the security pillar of the well-architected framework for our WordPress architecture. Call to action here is to use the well-architected framework. Use it as a learning tool, or use it just to familiarize yourself with understanding the guidance provided in the well-architected tool, even if you're just using it for the security pillar. And use it early on in your design phase so that you can incorporate the guidance into your application right from the beginning. Finally, here are some links for some useful information where you can get more information on the well-architected framework, as well as access to labs that can give you hands-on experience deploying some of the guidance provided in the well-architected framework. I'd like to quote Andy Jassy, the CEO of AWS, that says, "Security is job zero at AWS, which means it's even more important than your number one priority." Thank you very much, and I hope you enjoyed the presentation.